Let's talk about fractions and units in Autodesk Fusion 360. I've been watching the Autodesk Fusion 360 channel and its live stream series called 360 Live, basically since it started with Brad's first video, and even before that I was watching Lars Christensen's live videos where he recommended watching Brad, so thanks for that, Lars. I want to start off by saying that the guys presenting those live video streams are plainly awesome. Brad, Jason, Angelo, Aaron, and lately several others as well. If you are into Fusion 360, you must subscribe to the Autodesk Fusion 360 channel. I will have a link to it in this video's description. So it was because of my admiration for those guys that I was surprised when I was watching 360 Live advanced sketching, which I absolutely recommend, and heard Jason say the following.
And let's talk about fractions. So you'll probably notice that when you're putting in dimensions into Fusion, we use the decimal system. So it's like 4.0 inches or 4.0 millimeters, 4.125 inches or 4.125 millimeters. We're not really doing 4 and an eighth.
Jason then goes on to explain that you can actually use an equation like 4 plus 1 divided by 8 inches. I was almost sure that I could enter actual fractions, so I opened up Fusion 360 and tried it out. In this video I would like to show and share my conclusions with you. Okay, so as I thought, it turns out that you can do fractions simply by entering them in the following manner: 4 and an eighth. So this works. This is limited to fractions with the denominator that is a power of 2. That means 1/2, 1/4, or 3/4. This goes up to 128, but you cannot go above that. Also, as I said, you cannot have something like a third or a sixth or whatever, only powers of 2 in the denominator. So what can we do if we do want to use 4 and a sixth? We can use Jason's idea and just turn this into an equation, and this does work. Even so, when Jason in the live stream tried to do his 4 and an eighth, he wrote it like this and got an error. So why is that? The problem here is with the parser that interprets the units from this expression. From my attempts to play with it, what I have seen is that the units can only be applied to numeric literals and not to expressions as the 1/8 within parentheses that appears in here. I will explain how to fix this in a moment. But before this, I want to say a few words about units in general and then about units in Fusion. So units are basic quantities of the thing being measured. So what are we measuring? We can measure time, we can measure weight, we can measure length, we can measure currency. We can see within Fusion, if we go to modify, change parameters, and we add a user parameter, we have an option to pick the unit of that parameter. Above the units themselves, there are different groups of the types of entities that are being measured. Usually when we are talking about measurements in Fusion, we are dealing with the length type of units. So what length types of units do we have in Fusion? As you can see, we have millimeters, centimeters, meters, microns, and for those that like the imperial system of units. There are inches and feet and yards and miles and even nautical miles and mils, which are thousandths of an inch, if I am not mistaken. We all know that you can't add apples and oranges, but in engineering you can add different units as long as they describe the same basic type of measurement. So you can add centimeters to inches or meters, but you have to be careful not to do this unless you really intended to do so. And if you're not careful in Fusion, you might happen to do that undeliberately. Let's jump back to Fusion and see how those things apply. So when we wanted earlier, or when we tried to do 4 plus 1/6 of an inch, or what we hoped would be 1/6 of an inch, we got an error. So now that we have a better understanding of this, what is actually happening here. So what is actually happening here is that this sixth is not a sixth of an inch, as we hoped it would be when we wrote it like this. It's actually 1 divided into 6 inches. And this one is not just 1, this is actually a 1 millimeter, because our default units are millimeters here. So if we want this to be 4 plus 1 inch divided by 6, we should write it like this. But we should remember that this is still 4 millimeters plus 1 inch divided by 6, and not 4 inches and 1 inch divided by 6. This can be seen if we just approve this, and we can see the result. And if we go and edit it again, you can see that the 4 millimeters, which are the default units that we have set up here, have been added to the 4. I want to now go back and ask a question. Why is this wrong? What could we do to modify this to get a suitable result? The issue here is not with the fact that we are dividing millimeters by inches, because, at least theoretically speaking, you can divide different units of length. This would result in a number that has no units, because both are length, so length cancels itself. But if we want to make this more appropriate, consider that we are talking about an area of 1 inch squared, and if we divide this by 1 inch, then we could talk about a length unit again. So you can see that the parser here is very sophisticated actually, and is very good. So even this type of oddities are acceptable. Let's go for a moment back to the parameters, because there we can do things that are not limited to being to requiring that the result would be a length. For example, let's calculate the ratio between meters and inches. So if we use the following expression, 1 meter divided by 1 inch, you can see that we already have a result. And this result, first of all, it shows, as I said earlier, that you can divide different types of units of length, and we get a plain number that has no units in this example. Let's try another thing. Suppose we want to calculate the cost of a block of wood. Let's say we have its width, which will be in millimeters or in meters, and let's say it's half a meter. Let's say we have its height, also set in meters, and have it at, actually let's say it's 40 centimeters. And for some odd reason, let's say that the length width, height, and depth, probably depth, or let's just call it D, will be in inches, and say it's 10 inches. Sorry, that would be here, 10 inches. Again, the expression here does not specify inches, but the default unit for this parameter, or the result of the expression, should be inches, and therefore we're talking about 10 inches in here. Now, what would be the volume of this cube? Again, we can decide, we can create a parameter for this. The volume is not a length unit. We have volume, liters, gallons, quarts, pints, cup. I would expect something like cube meters. Okay, let's leave it at this and see what happens. And say it's the width times the height times the depth. Okay, and we have the volume in liters. Now let's say that we know that the price for this type of material is $1,000 per cubic meter. It won't let us do this because, again, this would be an expression that has units, and unfortunately I don't know if Fusion has the option to just create any compound unit to work with. So this does not work in here like this. I cannot have a price per volume, that's actually the unit that I would like to have here. But nevertheless, if I will still use this and set the total price, not the actual price, and say that the total price, and this will have a unit which is currency, and those currencies are, the only currency supported here is dollars. And if we'll say that this is 1,000 of those times the volume, everything works fine, and the value becomes 1. Really? That is either a bug or the luckiest result ever. Let's see what happens if we increase this. Well, obviously we need to multiply this by the volume. Times the M times W times D times looks okay, I don't know where this line came from. So now this makes sense. So you can see that this works quite nicely, even though, again, I would have expected for it to be possible to have a parameter that has some compound units that are not basically the native units within Fusion, but cool, we can work around this anyway. So actually I am not cool with what just happened here. After all, we did come here to understand how units work and not to just ignore when they don't. So let me do this again. And the way I wrote this initially was like this. And the parser says that this is okay, but then we get this result of 1. Now, looking at this here, what I can understand why this is 1. You can see it has this L in here, which I later previously I removed. So this L stands for liters, as can be seen here. So actually what happened here was that we have 1,000 liters times dollars per meter cube, but 1,000 liters are exactly a cubic meter. So 1,000 liters divided by 1,000 liters multiplied by $1, we get $1. So the result here is okay, but why, when I write this and try to multiply it by the volume, it ends up converting this to this odd. Maybe volume is sort of a generic, I don't know. This seems as if this is going to remain a mystery. Maybe Jason can do a film about this, a quick video about this, and explain to me back why is this changing to that odd result. Well, I think that with this we will conclude this video. I'd like to thank you everybody for watching, at least everybody that watched up till now. I've learned that editing videos is a very difficult task. I hope you learned something about Fusion and units in Fusion, or units in general. And I hope to see you on the chat in the Autodesk Fusion 360 live live streams. See you there.